Here is a problem every QA engineer eventually runs into, and it usually happens at the worst possible moment. The tests pass on your machine. You push them to the repository. They fail in CI. Or they pass in CI but fail when a teammate tries to run them on their machine. Or they pass everywhere during the week and fail every Monday morning because something in the environment changed over the weekend without anyone noticing. The root cause in every one of these scenarios is the same: environment inconsistency. The Python version is different. The system library version is different. An environment variable is set on one machine but not another. A test dependency requires a system-level tool that is installed on your laptop but not on the CI runner. Docker solves this class of problem completely and permanently. When your test suite runs inside a Docker container, the environment is defined precisely in a text file and is identical everywhere. Your laptop, your teammate's laptop, the CI server, same Python version, same library versions, same system libraries, same environment variables. In this episode we are containerizing a pytest test suite with Docker. No Docker experience required. No complex infrastructure to set up. By the end of this episode you will have a fully portable test suite that runs with a single command on any machine that has Docker installed. And that is every CI provider in existence. Docker works by building an image, which is an immutable snapshot of everything your application needs to run. The operating system base, the Python interpreter, all your Python dependencies, and your test code itself, all bundled together into a single artifact. You define the image in a plain text file called a Dockerfile that lives at the root of your project. Here is what a Dockerfile for a pytest test suite looks like. The first line is from Python 3.12-slim. This sets the base image. The slim variant is a lightweight version of the official Python image that includes only what is needed to run Python, without the full development toolchain. The second line is workdir/app, which sets the working directory inside the container. The third and fourth lines copy requirements.txt into the container and run pip install. We copy the requirements file before the rest of the code because Docker layers are cached. If you only change test code and not requirements, Docker reuses the cached pip install layer and the rebuild takes seconds instead of minutes. The fifth line copies the rest of the project into the container. And the sixth line is cmd with pytest and your preferred flags as the default command. 7 lines. That is the entire Dockerfile for a basic test suite. When Docker builds this image, it creates a sealed, reproducible environment that contains everything your tests need and nothing else. To build the image, run docker build in your terminal from the project directory. Use the -t flag to give the image a name and an optional tag. Something like docker build -tqa-tests latest. The at the end tells Docker to look for the Dockerfile in the current directory. Docker reads the Dockerfile, pulls the base Python image from Docker Hub if you do not have it cached, runs each instruction as a separate layer, and packages everything into an image stored on your local machine. The first build takes 1 to 2 minutes because it has to download the base image and install all the dependencies. After the first build, Docker caches each layer independently. Subsequent builds where you only change test code and not requirements take 5 to 10 seconds because Docker only rebuilds the layers that changed. To run your tests inside the container, use docker run with the image name. Docker starts the container, executes the default command which is pytest, streams the output to your terminal exactly as if you ran pytest locally, and then the container exits and is destroyed. Every run starts from the exact same state. No leftover files from a previous test run. No cached browser session. No environment pollution from earlier in the day. Every run is a completely clean environment. That is the guarantee Docker provides. Environment variables are the correct way to pass configuration into a Docker container, and getting this right is essential both for security and for flexibility. If your tests need a base URL, an API key, a database connection string, or any other piece of configuration that changes between environments or should not be in source control, pass it as an environment variable rather than hardcoding it in the Dockerfile or the test code. Pass environment variables at runtime using the -e flag when running Docker run. For example, docker run -e base _URL equals https://staging.example.com-API_key equals your key value QA-tests latest. Inside your pytest code, read these values using os.environ.get. If a required variable is missing, fail fast with a clear error message rather than silently using a default that might point to the wrong environment. The security principle here is, never hardcode credentials in a Dockerfile and never commit them to source control. If you push a Dockerfile or a .env file with a hardcoded API key to a public GitHub repository, that key is compromised within minutes. Automated scanners harvest credentials from public repositories continuously. Use environment variables. Pass them at runtime. Store them in GitHub secrets for CI runs. This is not a Docker-specific best practice. It is the correct approach to configuration management in any application. Docker Compose is the tool that takes you from running a single container to orchestrating multiple containers together, and for API testing scenarios it is genuinely powerful. The scenario is this: you have an API test suite that makes HTTP requests to a backend service. That backend service requires a database to be running. In a real environment you test against a staging server, but staging has rate limits, it sometimes goes down for maintenance, and it shares data with other teams, which makes test data unpredictable. With Docker Compose you define all three services in a single YAML file: your test runner container, a backend API container running your actual application, and a database container. Run Docker Compose up and all three start together in the correct order. Your tests make requests to the local API, which reads and writes to the local database, and the whole thing is completely isolated from staging, from other teams, and from the internet. Every test run starts with a clean database. Every test run has a guaranteed, available, rate limit-free API to test against. This is how senior QA engineers build test environments that are stable, fast, and independent of external services. It is a level of sophistication that will stand out in any portfolio. Here is exactly what to add to your portfolio project to incorporate Docker properly. First, add a Dockerfile at the root of your project following the structure we covered. Second, add a .dockerignore file at the root that lists what Docker should ignore when building the image. This should include your virtual environment folder, the .git directory, any output or log directories, and any local .env files. A missing dockerignore means Docker copies your entire virtual environment into the image, which makes builds slow and images unnecessarily large. Third, update your README with a Docker section showing how to build and run in 2 commands. Copy this command. Run this command. That is it. Fourth, update your GitHub Actions workflow to build the Docker image and run tests inside the container rather than installing dependencies directly on the runner. This guarantees that what CI runs is exactly what you can run locally. A hiring manager who sees Docker in your portfolio project knows immediately that you have worked beyond a solo local setup. It signals that you understand how tests need to run in real engineering teams. In the next episode, we are connecting all of this to GitHub Actions in depth, building a full CI workflow that runs automatically and enforces quality on every push. See you there.